You probably best know continuity is the ability to draw a function without lifting up your pencil. Today, we're going to look at maybe trying to formalize what continuity means, and we're going to use what we know about limits to talk about exactly what conditions you need for a function to be continuous. But, just so you know, that whole idea of being able to draw the function without lifting up your pencil is what continuity is all about. As a matter of fact, if you look at 31 on your classwork, I can ask you a question, is this function, the graph of this function, continuous? And you all say,
no.
Gosh, that was scary, but thank you you came through in the pinch. As I could also ask you, where is this function discontinuous? So I could even do one better and say, tell me exactly where it's discontinuous. David?
No, actually, I have a different question. Did you hand out a classwork yesterday?
I did not. This is still from your chapter 1. I will give you something new tomorrow, though. A promise from me. Where is it discontinuous? Dan?
X equals 3.
X equals 3. It's definitely discontinuous, right? You had to pick up your pencil. And? Rachel?
At X equals 1 because of the gap.
Yeah, X equals 1. You have to pick up your pencil. You can't draw through that. So, let's take a look. Let's see. Give me a second. Oop, that's not going to work. I'll try it one more time. I'll try one more time. Nope. Okay. So we'll just do it here. All right. All right. So for A, it's the limit as x gets close to 1 from a little below of f of x. Who feels like they have that? This is you walking on the hill. This is the left-hand limit, right?
Isn't that from the right?
Is that a plus?
Yeah.
Oh my goodness. I need bifocals. This is horrible. I don't even wear glasses. That's really a plus?
Yeah.
Oh my goodness. All right. This is really bad. Yes, Alicia, you're absolutely right. I apologize. This is the right-hand limit. This is your friend walking on the path. So what does your friend think he or she is getting closer and closer to as he or she approaches x equals 1 from the right? All right, so Alicia's going to take this as we walk down. Your friend definitely thinks they're getting closer and closer to 2. Does that make sense? That your friend thinks the function is getting closer to 2? Weight's the force of gravity pulling down on you. Okay. You should probably check out the screencast. I'm guessing you haven't, judging by your incredulousness. And it was a good one, too. It was a really good one.
But what's that dot?
What is that dot? Actually, I'm going to call on you when we get to D. Alicia, who's your friend? Call on your friend.
Rachel? Okay.
All right. What? Where do you think we're getting closer and closer to, coming from the right-hand side? Yes, that's exactly what I mean. This is the left. This is the right. We're getting closer and closer to 1. Yeah, you think we're going to 2 as well. So, if Alicia and Rachel agree, who's going to be the big unifier? Who's going to bring Rachel and Alicia together? It's really not that hard because they agree. Morgan, what's the limit? The limit is 2. Rachel and Alicia are calling out to each other, I'm getting closer to 2. Are you? Yeah, I'm getting closer to 2 as well. So they're both getting close to 2. Now, Sam, what is f of 1?
It's 1.
F of 1 is 1. That's what this dot is. That's what the functional value is. Can I ask a question? Are we continuous at x equals 1? We're not. Alicia and Rachel agreed, right? Did Sam agree with them? No. So I want you to start thinking about who needs to agree in order to be continuous. All right, let's take a look as we get close to 2. So first of all, any questions? Because I feel like we can start moving through these quickly, but we should clear up any questions first. Rachel.
Yeah, I know there's like a dot at f of 1, but there's a dot and not is it just a random dot?
It's not a random
Or
dot.
does it jump down and go back up? You know how the
It's a
calculator
point.
takes out-
No, it's a point. It's not, the function doesn't go down there and then come back up. It's a single point. So, Rachel, here's your desk. Here you are. You're not in your desk.
So it's separate from the line completely.
But it's part of the function.
What?
It's just because you've been dealing with functions that always come in neat little packages that we
We
can.
have functions that come in there's going to be a point here and a line here and another
Sure.
point there and a line here and
Sure. Is this a function?
No.
Why not?
The 2 points at 1.
Where?
So the point doesn't.
Where's-
Oh, wait, no.
No, it's a hole.
It's a totally a function. For every input, there's an
I have
output.
a question.
Okay.
If there wasn't a gap in the line above the hole, if there wasn't a gap in the line above the point, would it be a function? Because wouldn't it hit 2?
Where? You mean if this was filled in? Where are you talking about?
No.
If this wasn't here?
No, if the app was there, but the gap
Oh,
above it was
if-
filled in.
Yeah, that would be a problem.
Oh, okay.
That would have 2 outputs for 1 input. Can't have that. Okay, so that's definitely a function. I agree, it's an interesting function, not a function you run across every day. Right? As a matter of fact, if I had to define this function, I'd have to define it as a piecewise defined function. Remember? Okay. Oh. All right. No, you did piecewise defined functions, right? Yeah, okay, fine. Oh, I lost you. Okay. We did piecewise defined functions. All right. X from the right-hand side as we get close to 2. Julia?
4.
I would agree, don't you think? Getting close to 4. Calling a friend, Julia.
Kelly. 4.
I think Kelly's thinking we're getting close to 4 as well. We're both getting close to 4. So since they agree, unify Julia and Kelly. Katie Rayner, what's the limit there? It is 4. And now, Katie calling someone to tell us what f of 2 actually is. It's 4. Is the function continuous at 4?
Yeah.
Check it out. Julia, Kelly, Katie, Dan, they all agree, and somehow we're continuous. We had a problem before. At x equals 3, are we going to have a problem, do you think?
Yeah.
Probably. That's my guess. Arnie, as we approach 3 from the right-hand side, what do you think we're getting closer and closer to? You do think we're getting closer and closer to 1. Totally agreed. David Bellier, as you approach 3 from the right-hand side, what do you think we're getting closer and closer to?
Or wait.
What did I say? What is wrong with me?
Wait, so which side am I approaching this from again?
From the left.
Okay. In that case, 2.5.
How about, can we say 2.6? Does that work? 1, 2, 3. Yeah, 2.6. All right. So here we have Arnie and David who think we're getting closer to different things. Ian, do you have any hope at unifying them?
Probably not.
No, definitely not. They are at opposite sides of the room, opposite sides of the world. They are thinking we're totally going to different places. So we would actually say that the limit, I know you wanted to say it. The limit doesn't exist because Arnie and David don't agree. So if you don't agree from the left and right hand side, that limit doesn't exist. However, just because the limit doesn't exist doesn't mean the function doesn't exist there. And so here is the interesting question, what is f of 3? Be careful. Make sure you're looking at the right place. Make sure you don't get caught off guard. Make sure you don't tell me what the... Actually, What's the wrong answer? And I know there are lots of wrong answers, but I'm looking for the right wrong answer. The wrong answer is 1. It's definitely not 1. What is the right answer? What's f of 3? 2.6. It is. Okay, so, but because we're not in agreement, we don't have continuity. At 4, do you think we're going to have any problems? No. Probably not. All right, Sam, the right-hand limit of x approaching 4?
1.
You sure?
0.8. Yeah, it's like a little bit over 0.8. Oh, yeah.
All right, good. 0.8. What do we have? I don't know. Morgan. Great. Drew.
0.8.
Great. And just because it's so much fun, Katie Rumor. 0.8. All in agreement? Are we continuous? Okay. Nice. So I think if we actually had to start talking about what it means to be continuous, we would say the limit, the right and left hand limits agree, the limit exists. We could probably just say the limit exists. And the functional value exists. And not only do the limit and the function value exist, but what needs to be true about the limit and the functional value. Yeah, the limit and the functional value need to be the same to be continuous. If they're not, the limit can still exist, right? We still had a limit here. The functional value can still exist, but if they don't agree, then it's not continuous. Let's see. Let's take a look. I'd like to take a look at 39, and then maybe we can go back and look at like some of like 33 or 34 or 35. But did we make that clear though? Right, for it to be continuous, you have to have a limit that exists, a functional value that exists, and they have to agree, they have to be in agreement. Alright, so for 39, here's another one of those find k sort of things. We need to find a value so that the function is continuous. And look at this, it's a piecewise defined function. Right? It's defined as 2x plus 5 when x is less than 4, and it's defined as x squared plus something when x is greater than or equal to 4. Now, would you agree that there are probably lots of values of k that would make this function not continuous? Can you imagine a function, what was it, 2x plus 5? So 1, 2, 3, 4, 5. So it has a slope of 2. 1, 2, 3, 4. Okay, I got to do this again. I know what I'll do. Let's see if this works. It does. Okay, so the function's defined like that when x is less than 4, and it's defined as some quadratic, some parabola, x squared plus k. Well, what does the function x squared look like? I just said it. What is wrong with me? What does x squared look like? Alright, what is x squared plus k going to look like? Parabola shifted up or down? So would you agree that if we took a parabola and shifted it down, that would not be continuous? So we're going to need to find some parabola that we shift up such that it meets perfectly where the line left off. Can I give you like 30 seconds to think about it? And then you can tell me whether you need a calculator or you don't need a calculator, or how we could go about doing that problem. We want to make it continuous. We need to find some k value that's going to work and make it continuous. Oops. What'd you get? Did you figure x squared plus 5 will do it? Alright, so I'm doing it graphically. If you look at, I have 2x plus 5 defined on the interval x less than 4. Alright, and now I'm going to do, whoops, I missed something.
How'd you get that thing in there?
It's the second math, which is the test button.
Thank you.
Oh no, it froze. This is actually this program. This program has done this before. What a bummer. Alright. Alright, so the question is, does 2x plus 5 and x squared plus 5, do they meet at the same point when x equals 4? Alright, when x equals 4, what is 2x plus 5 getting closer and closer to?
13.
I would agree. This one's getting closer and closer to 13. When x squared plus 5 is close to 4, what is x squared plus 5 getting closer and closer to?
21.
I think that's going to look like this. X squared minus 3. Alright, what happens? Oh, interesting. Huh. Yeah, I just thought of something I didn't think of before. What is x squared minus 3 getting closer and closer to when x is getting close to 4? 13. That's interesting. Actually, so that's a parabola that's been shifted down 3. And so this parabola, I guess, looks something like this. But we don't see that bottom part, right? How'd you do it, Drew?
Well, yeah, I figured because x squared is just from the origin going up on both sides, so but normally it wouldn't intersect 13. But basically, so you plug in for x to see the y value that it crosses on the first equation.
Okay, so 2 times 4 plus 5, so we get 13. So f of 4 is 13 for the first equation,
Right.
and we know that it also has to be, right, f of 4 is going to have to be 13 for the second equation. So we need to set x squared minus k equal to 13.
Plus k, but yeah.
Oh, plus k, you're right. So when I plug 4 in, I get 16 plus k equals 13, k equals negative 3. That's exactly right. I'm a little disappointed that didn't work. Oh well. Alright, so continuity tonight. Have a terrific Tuesday, and we'll see each other tomorrow.